Hi, we'll go through CUDA programming now. Let us fire up a Colaboratory notebook. Here, in this one, I already ran the setup commands. Now I have removed the existing CUDA installation and NVIDIA drivers and installed a specific version of CUDA that works for us. And we'll check for the installation check. Then we install a extension of Jupyter Notebook. I'm using a fork of mine because it's important that we own a certain we try to have as much control over the software that we use as possible for security reasons. Then we can load this extension. Once we install this extension, we can load it, and once we load that, we will be able to use this liquid tag. Collab. Let's go for the collaboratory documentation as to how to use it. Yeah, we have collaboratory documentation facts, and here we go. Okay, here I'll have drive mount. Why do one important thing here to notice? Okay, okay. What I'm trying to search is what is this? The start to Jupyter custom code. How to run custom code in Jupyter? Running custom code in Jupyter and well means. Okay, for now let's take it at face value. Face value. Let's keep it in such a way as, for example, this exclamation mark. What it do is it tells the computer, tells the notebook to run the operating system commands, terminal commands. We see it is a Python notebook. So whenever we run some command here, it is, for example, here we write a command like 2 plus 3 x is equals to 2 plus 3, which is Python. I just run it. I'll get the results in Python, which is 5. So this is a Python code, and as far as the operating system commands are concerned, we cannot run them with this without this exclamation mark. Okay. Okay, once we have installed the CUDA setup and installed a plugin, we can run the CUDA code .cu. We generally denote this as an extension. We can do the same for Markdown and Markdown files and other specific files. And here we include IOStream. This is basic C code, C++ code here. A main function which output is this is from CUDA string. Now let's go for an involved example in which we have maximum iterator. See, the Colab provides a rich set of options It shows the API documentation. It shows the API documentation on the fly. So we could see what is the meaning of when we hover when we hover the cursor over it, and we will be able to see the documentation as something like this. For example, what is an integer? Integer is generally a primitive type, so convert a number or string to an integer, or return 0 if no arguments are given. And there is an example here. First of all, it tells us the uses of the integer and context about it, and an example. Okay, we can even try this. Okay, let's try this. Since this is Python code, I can just run it directly in the shell. So its answer is yes. So 0b100 base 0. It's a boolean. It's a decimal number, not decimal. It's a 0 1 1 thing, binary. Binary. It's not even binary. Anyway, something. Using namespace standard, you have global means the code that runs on the device. Here, the device means a GPU device, a GPU enabled device. Host means the operate. So system which is different from the GPU device, and where we run the lifecycle commands or the housekeeping commands, or the scaffolding. The main kernel or thread execution happens inside the GPU. Then we run this code and we'll be able to see the outcome. The maximum element is this 956750560, and the time required to execute this one is 0.003232. Then we'll go for another example where we could see these brackets. So angular brackets, we call this angular brackets, and 1 1. So 1 1 is a parameter. So invoking the kernel function on the GPU with one block of one thread. Check for error codes. Check for error codes. Remember to do this for every CUDA functions. So for every CUDA function, you need to check for the error. For example, we have this function here, kernel. Then if we write another one like this, for example, kernel2, we need to run the same check. Run the same check. So this is pretty standard for everything, and you'll get a hang of it once you know it. So like this. Okay, kernel2 is undefined. Kernel, yeah. Okay. This will tell you how many threads are there. For example, here we could see this is what it is: kernel, parallel kernel, and this kernel opens the fires up at grid on the device for execution. So this is a host, and host which is one computer, the computer that you use to invoke the first command, the command to run this whole code program. We'll see here. Let's search for errors inside this. Control F, errors, checking. So I'll check for error checking. Error checking here is checked like this. So kernel launches do not return any error code. So CUDA p get lost error or CUDA get lost error must be called just after the kernel launch to retrieve any pre-launch errors. So we get pre-launch errors to ensure that any error written by the CUDA p get lost error or CUDA it get lost error does not originate from calls prior to the kernel launch, one has to make sure that the runtime error variable is set to CUDA success. So the runtime error variable should set to CUDA success just before the kernel launch. So before launching the kernel, we need to set that. So how do we do the CUDA success? Here, CUDA device synchronize, CUDA success. Okay, let's see that. Let's see how to do that. Yeah, here we go. To pair memory copy kernel we have, and we have CUDA memory copy pair. Here there is no error. Okay, we'll check the properties. Kernel sync.